So far, we've learned what a limit means, how to estimate limits using table, and how to estimate limits using graphs. But here's something very important. Not every limit exists. Now, let's talk about situations where a limit does not exist. A limit fails to exist if the function approaches different values from the left and right. Let's look at the example. We are finding the limit of g of x as x approaches 2. Look carefully at the graph. As x approaches 2 from the left, the graph approaches one y value. But as x approaches 2 from the right, the graph approaches a different y value. Since the left-hand limit and the right-hand limit are not equal, the overall limit does not exist. Even though each side has a value, but they are different. So we say the limit does not exist because the one-sided limits are different. For a limit to exist, the left-hand limit must equal the right-hand limit. If they are different, the limit does not exist. The second case is when the function values increase or decrease without bound. This means as x approaches a number, the function keeps going up toward infinity or down toward negative infinity. It never settles at a single number. Look at this example. We are finding the limit of h of x as x approaches 2. As x gets closer to 2 from both sides, the graph shoots upward. The function grows larger and larger. It does not approach a fixed number. So we say the limit does not exist because the function increases without bound. Sometimes we say the limit is infinity, but technically infinity is not a real number. So whenever the limit is infinity or negative infinity, we say the limit does not exist. The third situation where a limit does not exist is when the function oscillates. That means the function keeps moving up and down and does not settle on one single value. Let's look at this example. I want to find the limit of the function sine of x over 1 as x approaches 0. Let's look at this table. As x approaches 0 from the left, here are the function values. And as x approaches 0 from the right, here are the function values. The values are not getting close to one number. They keep switching from positive to negative to positive to negative. Sometimes near 0.5, sometimes near negative 0.8. There's no pattern showing the values settling toward one single value. As x gets closer to 0, the function keeps bouncing back and forth. It never settles. Because the function does not approach one single value, so the limit of this function as x approaches 0 does not exist. DNE stands for does not exist. The limit does not exist when the left and right sides approach different numbers. The function increases or decreases without bound. The function oscillates and does not settle.